So today we are trying to understand the concept of threads and multi-threading. So what is a thread? What is a multi-threading? When we are calling it as multi-threading, or what is the importance of implementing the multi-threading? What are the advantages and disadvantages over the multi-threading? So this kind of scenarios we will try to understand, and we'll try to implement small things also with respect to threads. And I'll give you the reality of multi-threading programming nowadays. What is and all we will try to understand. Okay. Yeah, so let's come back to the thread. What is a thread? First of all, what is a thread? So we used to call it as thread, but what is the point of thread? Right? So generally in our day-to-day life point of view, we know what is a thread. It's just like a small teeny, okay, just piece of thread, right? So that is what comes under the thread, right? So if you take a thread means just we used to follow this teeny thing called as thread, right? It is all just like real, I mean, on our real life point of view. But now let's come back to the programming point of view. What is a thread? Sorry. Okay. So generally here the thread is, I'll give you a statement and then we'll understand practical point of view. What is a thread? I'll tell you. Thread is the teeny or smallest part of process, tallest, smallest unit of or part of process. Yeah, just try to understand with your answer it is correct or not. Okay, which runs independently. So thread is the smallest part of process. So that means we have to understand again what is a process. So thread is the smallest process, smallest part of a process which runs independently, So that means what I'm trying to say here it is, if you are having a process, then it is the smallest part. That means a process may contain multiple threads. So the above statement in what it is saying, a process will have multiple threads. So that means there is a possibility of a process contains many threads. That means, right? So whenever I said like it is the smallest part means as part of process means that means process will have many threads. Now what is a process again here it is. What is a process? Yeah. So generally if you go to the system, when you open the task manager, I'll show you the processes. See, if you go through this, generally what are all this, if you observe here, what is this? Processes. So in your system, to do something, whenever you are opening any software application or whenever you are doing something or whenever you started your system itself, your operating system is running. Lot of process in the backend. So a lot of process in the backend. So that means what is these are all things, whatever you are seeing in this case. Yeah. So whatever you are seeing here, okay, sorry. Here, whatever you can see here, these are all processes. Google Chrome, IntelliJ IDEA, whatever it is, Zoom meeting, so on, so other things, your Java language. See, it's not about the softwares what we are using. Your entire operating system itself is software, right? So that means your software system is having lot of processes. Your system, our systems are always having lot of process. So these are all comes under the process, guys. So that means what is the statement I can give you here one more time is, okay, a process is a process is the instance of a process is an instance of a computer. A process is the instance of a computer program, that because whenever you are executing the programs or nothing but a software that is being executed by one or many threads. So that's what above statement also I'm saying. A process will contains sometimes many threads. So that means process is the instance of a computer program. That means whenever you implemented some software, okay, the moment you are executing that software means it's nothing but your a process is begin. A process will begin. So that means with respect to thread point of view, process is superset. So if you taken this as a process, and process will have internally threads, thread 1, thread 2, thread 3, thread 4, like that you will have multiple threads, one or many threads. So these are all comes under the threads. So ultimately here the overall process is nothing but internally the group of threads. So if you see here again task manager point of view, so these are all processes now. So they see this is the process, it is saying very clearly. And this process whenever you are executing, for example, if you taken this Zoom meetings or whatever it is, in the back end these many sub processes are running again. So sub process means again in the behind of these things some threads are executing. So okay, some threads are getting executed. So these things will be called as. Now one more thing you have to observe here. Processes, each process is utilizing what? CPU, memory, right? So some hard disk or network, whatever it is. So how much CPU your process is utilizing? So in this case, Zoom meeting is utilizing 5% of CPU, and it is utilizing so and so MB of memory, RAM memory. So that means each process will always occupy some CPU utilization as well as memory utilization, especially RAM memory point of view. Okay, that is what the importance of, that is how the process will execute in every system or every computer generally. So these are all comes under the processes. I don't need you to, you need to worry about it. Can I show anything else? Startup apps. Manager. See, these are all. See, even I can show you this one also. This is also important. See, these are all things as a when you are getting an experience in your as a developer, you will come to know step by step point of view more system wise or computer things point of view. You will come to know this process IDs, all these things, guys. Okay. So PID, I just shown you earlier process, right? In a computer system point of view, computer point of view, where every process will have its a unique ID. Okay. So generally process IDs. Now whatever we taken earlier, Zoom, all these things, right? I said process. Now if you go to the every process will have a process ID, individual process IDs. You know we can kill these processes also. So that is all. See, these are all running process. See how many processes are running in your system. If you are stopping all these processes, your system will not work. That means you are killing all the Chrome instances and everything. See, you know how much memory Chrome will occupy generally? Lot of memory from your system. Mm, so that's why I think you saw some memes also somewhere else. Other browsers will occupy only less amount of uh, your RAM memory or your CPU utilization, but Chrome will occupy a lot. So definitely, when something is giving more features, means definitely it will occupy more. But as a technical person, we can understand all these things. But as a regular user, system user point of view, they can't understand. People are more familiar with Chrome browsers nowadays when comparing with what Firefox or maybe something like in Edge browser. People will like always Chrome only. Yes, definitely Chrome is good when comparing with other, but Chrome is occupying a lot of memory also. So that is also, see here how many processes are running for a single. I opened only one or two instances of Chrome, but still how many processes are being used. And if you see here, I IntelliJ IDEA. Okay, so this is also just now IntelliJ IDEA. So this is also one of the process ID opened by Dilip Singh. That means I only opened it like that. So everything. So database is running in the behind. When you are installing the databases in your computers, Java will have. We will install Java, right? I think Java will also have. The moment you started your system, Java will also have some kind of, see here, java.exe. So this is also taking some process ID. So every process ID is something like unique ID point of view will have. So these are all processes, guys. Now how these processes are getting executed means internally again these are all things are having, these are all having threads. I don't know. See here you can end the tasks and all, but don't do that. So if you are doing end task means then your IntelliJ will be closed like that. But don't touch all these things if you don't have the confidence on this. Otherwise, your system will corrupt if you are doing on wrong things. Okay. Anyway, so this is all about the processes point of view. Just I would like to show you in practical point of view. These are all processes. So this is the process only we are talking about right now. Okay. Uh, yeah, fine. So now you are good with process. Now these processes internally again contains threads. So it may be one thread, it might be more than one thread also. That is what about the thread here it is. So a thread is the smallest part of a process which runs independently. So that means in a process, whenever you are having many threads, every thread, okay, will have its own execution process. Every thread will perform its own, okay, execution activity individually like that. You are having multiple threads in your process means every thread will have its own execution process. Every thread will try to execute its own functionality internally whenever you started any process. The moment you started process means internally it will start threads. Now in this case, as part of Java development point of view, what we are trying to understand here it is, we are trying to understand today is how, what is it this thread and how this thread is getting started, and how we are in Java, in case if you want to create multiple threads, can we create or not? From the programming perspective, can we create these threads or not? Yes, we can create. How to manage this multiple threads is called as multi-threading. So whenever you want to manage these multiple threadings to avoid some other problems, that is called as multi-threading point of view. In this case we will say that step by step point of view. So first point of view, we understood what is a thread in a theory point of view, right? Now with respect to the programming point of view, what we have to understand is how to create threads. That is the first important point. So now the process is, what we are going to understand is with respect to Java point of view, how to create threads. How to create a thread. So that means if you taken some real-time applications point of view also, um, especially some games or even our banking applications point of view also, but let's take some things like games point of view. Especially games point of view will have more threading concept generally. See, when you are playing the online games, especially, or when you are playing with online games, especially, we know some today we are having a lot of online games, right? So if you take in any online games, parallelly, so many in a single game itself, lot of, okay, people will be there, and every person, every gamer will try to do some activity, and other parallelly some other, okay, gamer also will try to do some other activity. So that means parallelly so many things will happen in the single game, and everyone is working, and every gamer is pointing to only sometimes only single target or whatever it is. So that means what you are trying to understand is many people are there, and many people are always, okay, working simultaneously or parallelly means parallelly. So they are working just parallelly point of view. I mean, working in the sense just they are playing the game. But in the behind of this software, the game software, okay, people has to update the what, so that calculations are the results of the every gamer. So you will see, right, dynamically where how much game you completed, what are the targets you reached. So that means these are all things should be happen, okay, with respect to this results or whatever it is, to each and every individual person point of view. To the each and individual person point of view. So in this kind of generally this kind of okay things, people will go with multi-threading concept. People will implement multi-threading. So and I'll tell you the reality of multi-threading programming later. So just people will go with this kind of multi-threading, and I'll give few more examples also later as part of our process. So people will implement multi-threading in very specific scenarios, but not every scenario. Okay, so don't think like in the organization when you join into a project, every project will contain multi-threading. In my career, I'm telling you the truth. Okay, 90 percentage of, or I can say like 95 percentage, 95 percentage I never worked on multi-threading. Not only me, any application. So that means when I'm verifying with others also, so they said like yes, they worked on multi-threading for just like one small piece of work or one kind of small functionality point of view. They implemented the multi-threading. That means in their career also they implemented 90 percentage not multi-threading. So that means no more, no multi-threading programming, no multi-threading programming. So here also myself also no multi-threading program. But why still multi-threading is more popular? I'll tell you that reason also. Okay. So we will see that why it is okay still a popular and what is the need of knowing about it. And in reality, it's not that much. Okay, you are going to write every time multi-threading programming. So what is how it got reduced writing the multi-threading programming when comparing with previous years? We will try to understand that later. So now the point here it is, first of all, okay, now finally we are trying to understand a process is a collection of thread, and a thread will perform individually, internally as part of the process point of view. And now how to create threads in Java, we have to understand. So tomorrow when you are working with multiple multi-threading programming, you have to work on threading environment or multi-threading programming you have to implement means you have to know first of all how to create the threads. That means the first point here it is creating threads. We should know. And then once you are creating multiple threads, managing the threads. That is what multi-threading. So it's not about only creating the threads. As a developer, we have to implement some kind of logic, some kind of functionalities to manage the threads also. Managing threads means which thread has to be executed, okay, with priority, which thread should not be executed with priority, which thread, like that you are going to handle managing threads also. So these two topics we are going to understand. Let's try to understand. So let's take the first one, creating the threads. So in Java, by default, okay, by default in the sense Java provided, with respect to our core Java point of view, Java provided we can create thread in two ways. We can create thread in two ways. See, in Java, everything is an object, guys. So here in this case, thread is nothing but Java point of view, again object only. See, whenever we discussed about exception handling, exception is nothing but what, with respect to Java point of view, object only. An exception created means object got created. A thread is created means an object only. But when we are saying a class as a exception class, now for example, can I call this class as a exception class? No. Is it an exception class means? Answer is no. Why? It's not inherited from any exception class. So if you are inherited somehow from the exception family, then it is exception class. Then I can call ABC as an exception class. Right? Similarly, with respect to threading point of view also, creating threads means don't think like something else. It's nothing but a special class, special object that we are considering as a thread. Okay, that will have threading functionality internally. That specific object will act as a thread or with some specific privileges with respect to multi-threading point of view. So that is how you just need to think about thread. So let's come back. What are the two ways we are having is, the first one is by using thread predefined class called as thread class. We have a thread class. Second one is we have some by using runnable interface. Runnable interface. So by using these two concepts, we can create the threads either using thread class or by using runnable interface. We can implement or we can create the threads in Java programming. So that means now if I take in same ABC class, can I call it as a thread class means? Is it that thread class means? Answer is no. Why? It's a simple Java class. It's not a thread class. It doesn't have any thread. So the moment you created object for the ABC class, ABC object, then it's not a thread. How can I say it's not a thread? Because it doesn't implement it by using either runnable interface or at least by extending the thread class. So there is no relation with any threading functionality. That's why it's not a thread class. So that's why it's not a thread object. But if you are somehow the ABC class is making relation with either thread or runnable interface point of view, then your ABC class is acting as a thread. Then your ABC class becoming as a thread. Nothing but if you created the ABC object, then it is a thread only. Then it will become as a thread. So, but anyway, we'll see that. Just that means why I'm giving this kind of things is tomorrow if you got some class, how will you identify it as a thread class means this is how you just need to explore the things. You can easily understand it. Okay, so now let's come back to the first approach, how we are creating the thread, and then we'll go with second approach also. So by using thread class, how we are going to create our own threads. So here again, I have to take one more point, guys. In general, we have two types of threads. In general, we have two types of threads. Okay, leave about this. I'll come back. In general, we have two types of threads. Yeah. So we have two types of threads. We have two types of threads in general. What it is? First one is user-defined threads. User-defined threads. So user means in this case developer. So that means what are the threads we created manually? Those are all called as user-defined threads. Manually in the sense via programming point of. So that means as a Java developer, now whatever the process we are understanding, the way you are creating the threads comes under the user-defined threads. That means as a programmer, we are going to create our own threads as part of our programming point of view to execute some task. So those are all comes under the user defined threads. Those are all comes under the user defined threads. Nothing but created by whom? Created by the programmer. So these are all this life cycle of these threads, managing these threads, everything is done by a programmer point of view. Nothing but programming point of view. Okay, so just for to execute some specific tasks. This is what we are doing right now. How to define the threads, that is what we are going to learn now. And second thread is, so in your system, I shown you right processes, nothing but what? Lot of threads are already running in your system. When I shown you Java language also running, right? A process Java is also running. Nothing but in the background, already Java language itself came up with its own threads, right? That you can't handle it because that's already came as part of the software, whatever you installed. Okay, internally they came up with some softwares, sorry, some threads that they are came up with some threads. So that means system threads. So whenever I open the task manager and I shown you the processes, right? These are all processes. These are all process means internally these are all using threads. Now these threads we are not created. These threads came as part of the software. Okay, see this along with Java language, whatever it is. So these are all background threads are running, right? Those threads will be called as daemon threads. Daemon threads. Daemon threads. So that means daemon threads means what? Which are system, I mean, which are part of system process itself. You are not created these threads. These threads are already created by the system applications when you install or when you started any softwares. Okay, so nothing that these things will be called as generally background. background threads. So background threads. Okay, background threads. And what these daemon threads will do is these daemon threads only will manage user defined threads. User defined threads. That means whatever the threads we are creating based to do some specific task by via programming point of view, those are all user defined threads again managed by the daemon threads. In interview, they will ask you guys what is how many types of threads we are having. It's not how to create, understand the point. How many types of threads? You can mention like user defined, daemon thread. Daemon thread means user defined means as a programmer, okay, the way how you are creating the threads and all comes under the user defined threads. Daemon means which are already okay available as part of our system or software applications. Whenever those are all just calling as a background threads, and this daemon threads only will manage the user defined threads. This daemon threads only will manage the user defined threads like that. So in Java, you have some daemon threads. Okay, I will give one example later. So that means even though you are not doing anything related to that, but Java is already have some kind of threading programming internally and so related to some topics, and they will run parallelly internally. Okay, so what and all examples we will see later. Leave it. Yeah, one thing I can say like garbage collector also. So generally, what is the point of garbage collector? Usually, whenever you are creating multiple objects, generally garbage collector what it will do? Unused objects it will clear. So generally, what generally garbage collector in our real life means what? The people who are collecting the garbage, nothing but unused things. What becomes waste, right? Similarly, in the JVM memory point of view, whenever we are keep on creating the objects, we are utilizing the objects. Sometimes what will happen? Your task is your execution is completed. Now that object is become okay unused or unreferenced, unused in simple point of view. Then what internally Java program will do is by this garbage collector will run always. What this garbage collector will do? It will go to that respective object. It will destroy that object. Nothing but it. What it is doing? It is making this free space. So by removing that object, by destroying that object, it is collecting that object is nothing but it is destroying that object. So it's making free space in the JVM level. So now in this case, this garbage collector will run always. This garbage collector is keep on running. That is defined as a daemon thread point of view. So that, but in this case, now what we are understanding is how to create user defined threads point of view. So let's come back. Two ways we can do that. Let's take the first way by using thread class. By using thread class. So later we will understand tomorrow little bit about multi-threading also. First we are understanding a basic thread, then we will understand what is the multi-threading and what how it will operate, what are the advantages. Even we have disadvantages also. Okay, so we will discuss disadvantages also. Okay, so by using thread class, then how to create here, let's try to understand. So thread is a class. Just go to the project. Let's do one thing, new project. Okay, so just let me create a package. Okay, so now when it comes to the by using thread class means what we are going to do as a developer here it is we will inherit above, we will inherit thread class. We will inherit thread class. Well, inheriting the, that means simply by inheriting the thread class, you are going to create a thread. That means now let's take a class, some class I am taking here it is. Okay, whatever it is, just first thread is the class. Now can I call this first thread class as a thread class? Means no, it's not thread class. It's not a thread class. So is this thread means? No, it's not. Why? It's a simple Java class. It's a simple Java class. But to make a class as a thread class are nothing but creating a new thread, my first thread, what you have to do is you have to inherit the thread class. Inherit the thread class. And this is a predefined class given by the Java language. Okay. And runnable is also predefined interface. Predefined interface given by the Java language. Now let's go and extends. So inheriting means what? Extends. And what you are extending here? Thread. So you are extending thread. If you see this thread, which as part of which package? Java.lang package. So that means package dot thread. Java.lang dot thread. So now can you call this class as a thread class? Means yes. Answer is yes. Extends thread. Extends thread. So this is a thread class now. Okay, now this class, whatever first class is inheriting from the thread class means now you can operate your this class object as a thread. That means the moment we created object for this, or we are, I mean, one more thing we have to understand, then only your class object will become as a thread object. It will act as a thread. Okay, so what it is, let's try to understand. So generally, the moment you are creating the thread class, rule number one, point number one, you have to take this. Okay, I'll take like this. Step number one. Now the step number two is one more rule, nothing but what you have to do is step number two, point of view. Thread, as part of thread, we have to override always run method. We have to override always a run method. So what is that? Run method. So we have to override always with always run method with our own logic, with logic. So that means which logic you would like to execute under multi-threading, or which logic you're trying to execute as a thread, which logic, that specific logic you have to write inside the run method. So this is the mandatory rule. So let's see here, what I will do is, let me open the thread class first, logic, predefined logic. See, this is the thread class implemented by Java team. Okay, so if you see here, internally even thread class also implementing what guys? Runnable interface only. If you observe here, so if you observe this syntax, what it is this? Even thread also internally implementing the runnable interface only. That's what I said. Even as a user developer, as a developer, we can also directly implement this interface and we will create our thread classes. Even if you are doing via thread also, internally nothing but our thread class also nothing but internally implementing runnable interface only. So this point also you have to answer in interviews. They will ask you sometimes, what is the relationship between thread and runnable? Can you explain? So then you have to tell this point. That is why I just taken this code. So thread class itself internally implementing the runnable interface. That means if you are inheriting thread class from our own class, nothing but our own class also indirectly implementing what guys? Runnable interface. Now let's go to the runnable interface again. Let me open the source code of runnable interface. If you see here, what is this method? A run method. And if you observe here, this is what interface, guys? Functional interface. That means tomorrow you can, okay, provide implementation to this run method via lambda expressions also. Why? Because it's a functional interface. So in interface they'll ask you, do you know any predefined functional interfaces? Yes, one more thing is runnable. Along with function, supplier, consumer, predicate point of view, one more is runnable also. So that means in the threading point of view, runnable is also a functional interface. So let me copy this one also. So yeah, so this is what runnable is an interface and it's having always void run method. So now understand why I said we have to override always run method with logic. With whatever the logic you would like to execute and as a thread point of view, that logic you have to write always inside the run method, whether it is a you extended via thread class or we created our own thread by using runnable interface also. In the second step point of view I said, right, runnable interface, then also, then it's very clear, it's having one abstract method means you have to implement it, there is no choice about it, right? So when you extend it, sorry, when you are implementing the runnable interface, you have to provide implementation for the abstract method from that class, then it will force you. But in this case, thread class is already provided logic. Thread class is already provided logic for run method. If you want, I can show you control O run. Yeah, if you see here run method. What is this? Why this logic, run method logic is already implemented by the thread class. Why it is already overridden? Because sorry, implementing the runnable interface. Thread is implementing the runnable interface. That means the moment it is implemented the interface means it has to provide or override logic of that single abstract method. Provide the logic for abstract method. This is core Java knowledge. I mean that basic interface versus implemented classes knowledge. So this is having one single abstract method. It is having single abstract method. That single abstract method is run method. That single abstract method is run method, and that run method is implemented by the thread class with some default logic. So if you go here, run method point of view, so it is implemented here. Now what I am saying, the moment we create our own thread class, like first thread we created, right? By extending thread class, we did that. Now what I said second point, we have to override the run method. That is the why I used a word called as overriding the run method. Overriding the run method. So what is the meaning of overriding the run method? It's already there in the thread class. That means your parent class. Again you are rewriting that run means what you are doing, nothing but overriding only. Nothing but overriding only. So now here we will write our own logic which has to be executed under the threading environment. Okay, that logic you will write inside the run method. So that means you are overriding the run method here again. You are overriding the run method again, here it is. So let's go and override the run method now and let's see. This method is a run by thread when it executes. Okay, so see here subclasses of thread may override this method. This method is not intended to invoke it directly. I'll come back this point. What is the point they are trying to say? Now what is the second point I said? Public void run method. So is it having any arguments? No. What is the written type of void? Sorry, written type of run method void. So can I apply override here? Obviously. Why? This run method is already there in the parent class. Parent class called as thread. Right? So that's why I'm saying like overriding. Now here I'm writing some logic. Okay, here I'm writing some logic. Here I'm writing the some logic. And let me write some basic logic. Sys out of first thread executing, started executing, So some logic, something I can write. Okay, some logic I just written inside the run method. Any logic. Now you can write any kind of logic in this case. Okay, tomorrow you can write DB logic, whatever it is, based on the need pointer. Now, this is what you have to do second step. What it is we have to override always run method with logic. Okay, which logic has to be executed on the threading environment, we have to override it. So once we've overridden it, step number three, step number three, okay, create thread object. Nothing but create thread means creating an object of our own class. Creating an object of our own class. Let's do one thing. I'll take main method. The program execution starts from the main method, right? So now see here what I'm doing. By using this first thread class, t1 equal to new first thread. So what I did here it is, I created an object for my class. Okay, nothing but the moment you initialized an object or you created an instance for your class, so internally you are creating a thread. Internally you are just creating a thread. Now to start this thread, now here one more point you have to remember guys. Step number 4. Okay, let's do one thing. I'll write like this. See, these are all things will be asked in interviews. Can you explain how to write a simple thread like this? What is the rules we have to follow while implementing the thread? What are the steps? Now, step number 3, what you have to do is you have to create your own class object. I mean, thread class object, nothing but. Now, you are just created an instance for the thread. Now, it's all about step number 4 is, okay, starting the thread. Starting the thread. See, with this step, what I can say, you just created the thread, but not started. But not started. Thread just got created. Now, what I'm saying is, step number 4, you have to start the thread. You have to start the thread. Start the thread means to execute this logic. Whatever the logic you written inside the run method, to execute that logic, you have to start the thread. But one small thing, what we have to remember here it is, please remember, note, the point here it is, in this case, to execute, in this case to execute logic of run method, okay, as a thread, as a thread or under threading environment, we have to call always, we have to call always, okay, predefined method, predefined method start from the thread class. Okay, so that means what I said here it is, to execute the logic of run method, whatever you implemented here, to execute that logic of run method, we have to, okay, we have to call always predefined method of, predefined method start from the thread class. That means in the thread class we have a method called as start. Let me show you that one also. Okay, if you see here, this is the method I'm talking about. So this is the method. So to call, to execute your logic of run method, you should not generally what we will do in core, I mean in general till today, to execute so and so method in general, what we used to do, if you have a class, you are having a method called as ABC method. Okay, to execute that ABC method, what we will do, we will create an object, object dot ABC method, we will call like this. Generally, this is the way we will do that. To call that specific method, we will define here. But what in this case it was trying to say is, in the multi-threading point of view, okay, what is doing in this case is, so why you have to call start method, we will understand tomorrow with respect to life cycle point of view. So we have to discuss once you got a little bit understanding about how to create the threads and all. Tomorrow we'll see some threading life cycle. Some stages will be available that we will understand. Now with respect to thread point of view, what we said, the method name is run method. The logic whatever you implemented under this run method. To call this run method, you have to take help of object thread object help object dot. You have to call start method. You have to call start method. So you are not implemented the start method in our Java class, in our thread class. We are not implemented. Simply we are calling start method. Now internally, what Java will do is, what JVM will do is, okay, the moment you are calling the start method, it will call internally run method. Internally, it will call the run method. So then only your thread is got initiated. Your thread. So now the logic, whatever you implemented in the run method, right? So that logic is executing under the threading environment. Executing under the threading environment. So executing under the threading environment. No, if you are saying no, I'll call run method directly. I'll call run method directly. What will happen? I'll call run method directly. What will happen? So these points we will discuss tomorrow. Like if I are calling run method only directly instead of start method. So Java is saying call the start method to execute the run method. So that internally it will start method will call the run method. Then only your logic is executing under the threading environment. Then only your thread is started. If you are making no, I'll call run method itself directly. I don't want to call start method. Then your thread is not started. I mean, the logic will execute, but it's not executed under the threading. So that differences we'll see tomorrow. But at least first understand how to call the start method. So if you are not calling start, that use case we will discuss tomorrow. So that means you are calling run directly instead of start. What will happen? What is the point and all? We will discuss this tomorrow. But let's execute first of all at least this point of view. Okay. So let's go to here now. Go to our program. Now what I said, let's call the start the thread. Start the thread. So to start this thread, what you have to do, T1 dot start. T1 dot start. Now the start method we are not implemented. From where it is coming? The start method from the thread class. From the thread class. I already shown you in the thread class. See here thread start. So internally it will take care. Internally it will somehow, this is all internally they will call run method or whatever it is. Okay, it doesn't, they will do that thing. Now see here, let me execute my program. Yeah, if you see here, your program is executed. First thread started executing 01, executing 0. So that means that's what, just loop point of view we written, right? So you called which method? Start method, but it is executed run method. So that is the rule we have to remember and we have to follow here when we created thread via in this approach like run method point of view. So, I mean, you will write logic which has to be executed under threading, multi-threading. You will write inside the run method as a thread, the logic what you want to execute via as a thread. But to initiate that run method logic execution, you have to call always start method, not the run method. So if you are calling run method, what will happen? If you are calling directly run method, what will happen? This kind of scenarios, we will do that. Okay. So now what I will suggest you is just practice until this stage. Like you can create one more thread from the same class. I'm creating second thread. Okay. Then T2 dot start. So that means you are created total two threads in this case, T1 and T2. So like that from a thread class, you can create any number of threads. So total two threads executed now. Total through two threads executed in this case. Right. So we will see if you are calling run method, what will happen. And these are all things. And how do I identify now? Now I said it as a thread. It is executed as a thread. If you are calling via run, it will not execute it as a thread. That is also I'll show you practically tomorrow. That is also I'll show you practically tomorrow. So let's connect on tomorrow. Continuation to this, we will see tomorrow. So can you please explore the notes text file wherever you get a chance? Yeah, sure, Deepak. I'll do today. Okay. I did not upload it from long days. I'll do today. Okay. Yeah. So just let's connect on tomorrow, but please practice until this. Just override the run method and write some logic, whatever you knows, and then just call via start method point of view and rest. From here, continuation to this, we will see tomorrow. If you call run method, what will happen and how to identify it as a thread or not. So those details we will discuss tomorrow, and we will discuss thread lifecycle also tomorrow. Then you will understand what is the meaning of start and all these things. Why we are calling start method. So that means for that you have to understand thread lifecycle. So we will discuss thread lifecycle tomorrow, and then after that we will go with multi